In this video, we are going to do some 12 questions, that is from trigonometric identities, questions based on trigonometric identities class 10th. And these questions can be asked as 1, 2, or some of them are even 3 markers, including I've taken one MCQ here. So let's begin with solving the first one. So in the first question, as you can see, we have to prove this is equal to this. That means you can figure out that our denominator is actually has now become the numerator. So for that, what we are going to do is to multiply this by 1 plus sign. Well, multiplying dividing by 1 plus sign will results to give you 1 square minus sine square. Let's figure out what I mean to say. Let's see if I divide this LHS with 1 plus sine. So we have 1 minus sine A over cos A. And as I said, if I multiply divided by 1 plus sine A. Now check here. So this is applying A minus B into A plus B is A square minus B square. That is A square, which is 1 square is 1 minus sine square A. And below you can see that this is cos A. We generally do not open the brackets of the denominator. Now further we can see that this is 1 minus sine square, and what is 1 minus sine square A? That is cos square A. So I can write this as cos square A, and then that whole divided by, this is what, cos A multiplied by 1 plus sine A. Now check here, this is square times cos, so I can cancel these cos, right? What I mean to say that here this is square times cos, so one cos get cancelled. At the end, what we got, cos A as the numerator and 1 plus sine A as the denominators. We'll say this is equal to the RHS, and then hence proved. Let's move to the next. Now in the second question, we have this as the LHS and we have to simplify it to get 1. So what you can figure out from this question, that 1 plus tan square, we can write 1 plus tan square. What is 1 plus tan square from here? It should be sec square theta. And likewise, if I say what 1 plus cot square from here will be equal to cosec square theta. So let's do that thing. So I can write this, the LHS now will change as 1 over, as I said, 1 plus tan square is sec square theta, and 1 plus cot square A is cosec square theta. Now, once we are done, let's see, we are left with 1 plus sec square. Now you have to figure out here, that is, what is sec square? Sec is what? 1 by cos. So 1 by sec square is cos square. But I mean to say that sec reciprocal is cos. So this is going to be cos square theta. And same way, we can see that sec is reciprocal of sine. So I can write 1 by cosec square as sine square theta. And finally, you can see that sine square plus cos square can be written as 1. So I'll write this as 1. So this is equal to the RHS. Now next, the third question. Now in the third question, it says 1 over 1 plus sine plus 1 over 1 minus sine is 2 sec square theta. So let's begin with taking LCM over here. So what you can see in the LHS, we have 1 plus sine theta, that multiplied by 1 minus sine theta is the LCM. And therefore we'll be multiplying 1 minus sine theta with 1, which is 1 minus sine theta, and 1 multiplied by 1 plus sine theta is 1 plus sine theta. Now we can see here that sine and minus sine get cancelled. So we are left with 1 plus 1, 2 in the numerator. Below, I'm going to apply the identity of A plus B into A minus B, that is equal to A square minus B square, right? So it's going to be 1 minus sine square theta. And this is 2 only. What you can see that from here, 1 minus sine square theta is what? Cos square theta. So this is going to be 2 over cos square theta. This is square, right? Cos square theta. So I'll write this as 2 cos²θ. Let's write down over here. This is equal to 2, and this is 1 minus sine square is what? Cos²θ. What you can see, this is 2 times 1 over cos²θ. Now check what is 1 plus cos²θ. It is sec²θ, right? So you can see that 1 cos and sec are reciprocal to each other. So this is going to be 2 times sec²θ. And I can see this is our RHS. This is what we needed to prove. Now let's move to the next. Now in the fourth question, as you can see, we have to prove 1 plus cot square over cosec⁴ plus 1 is equal to this. So now what we are going to do is, I'm going to write cot square, right? Splitting cot square. From here, you can see that what is cot square? Cot square can be written as, cot square is cosec square minus 1, right? So let's begin with writing that part only. So in the LHS, we have 1 plus, as I said, I'm going to write cot square, right? Cot square is cosec²θ minus 1. That's the only changes I'm making, cosec²θ minus 1. And that divided by the denominator, which is given as 1 plus cosec⁴, right? Okay, there's a bracket, so I'll keep it. Now, this is equal to, in the next part, what I can write this as cosec²θ minus 1. Applying the identity a plus b, a minus b, I can write this as a plus b multiplied by a minus b. A is what? Cosec minus 1. A plus b multiplied by a minus b, and below it is 1 plus cosec⁴. Now what you know that 1 plus cosec and cosec plus 1 is same, right? A plus b same as b plus a. So this get cancelled, and what we are left with? We are left with 1 plus cosec minus 1. Cosec⁴ minus 1. Well, from here also you can see plus 1 and minus 1 get cancelled, and we are left with cosec⁴ only, and that is equal to the RHS. This is equal to RHS. Now let's move to the next question. Now this one is very similar to the previous question. Here I'm going to write tan square, right? Tan square is sec square minus 1. So this is 1 as it is. The only change I'm making here is writing tan square as sec²θ minus 1, and then whole divided by denominator, which is 1 plus secθ in a bracket. Now this is equal to what? Now same way I'm going to write sec square minus 1, applying the property, algebraic property, identity is called a square minus b square, which is a plus b into a minus b. So it's a plus b multiplied by a minus b, and that whole divided by 1 plus secθ. Now here too you can see this and this get cancelled. What we are left with, we have 1 here plus secθ minus 1, right? So this is secθ minus 1. So check again, we are minus 1 and plus 1 getting cancelled here, and we are left with this is equal to secθ, and that is the RHS. Next is, let's move to the next. Now in the next question number, well, I lost the count, but anyway, let's continue doing this count of the order. So we can see that here we have to prove this as the LHS, which is in terms of sine cos, and to be converted as cosec. Well, I can figure out that we have this denominator of the first is same as the numerator of the second, right? In such a case, we take LCM, but keeping in mind, we will not multiply or expand the denominator. So I can say that the product of the denominator, that is the LCM here, is this, that is sine into, well, 1 plus cosθ into sinθ is same as this. Now we can see that this has to be multiplied by sinθ and this with 1 plus cosθ as for the LCM. So I'll write this as cosθ. This is cosθ square. Oh, this is sine, right? Not cos. And let me write again. This is Sine into sine is sine square theta. And this is 1 plus cos theta into 1 plus cos theta should give you 1 plus cos square theta, right? Just I have taken LCM and nothing else. Now for further simplification, what I can see that let this be sine square theta only. On this part, I'm going to apply a plus b whole square. On this part, I'm going to apply a plus b whole square, which is what? A square plus b square, that is cos square theta, plus 2 times a into b, that is a is 1 and b is cos theta. So 1 into cos theta is cos theta. As I said in the beginning, and it's very important to remember that we should never open the bracket until the, the denominator, until the last step of the solution. Now what next? Yeah, I can figure out that this is sine square theta here, and we have a cos square theta. So what is sine square theta plus cos square theta? Well, everybody knows sine square plus cos square is 1. So I'll be writing this as 1, and there is one more 1. So 1 plus 1, that will be 2. But that's the next step. It's 2 cos theta. Well, it's monotonous, but I always will keep on repeating that we do not open the bracket, because if you open the bracket of the denominator or you do any method of expansion, you will not get the RHS. Well, I should say that in 9 out of 10 or maybe 1 out of 100 cases, we open the denominator. So let's see now what you get here. This is 1 plus 1, 2. And this is 1 plus 1, that is 2 plus 2 cos theta. And that divided by, this is sine theta multiplied by 1 plus cos theta. Now what in case if I take 2 common from the numerator, if I take 2 common from the numerator, what we are going to get inside is 1 plus cos theta. Right, we'll get 1 plus cos theta, and below we have sine theta multiplied by, this is sine theta multiplied by, what's there inside? That is 1 plus cos theta. So check here, this get cancelled. So this and this get cancelled. So we are left with 2 over sine theta, right? We are left with 2 over sine theta, which is 2 multiplied by 1 over sine theta. And what is 1 over sine theta? 1 by sine is cosec. So we'll be writing here cosec. So the answer here is 2 cosec theta, which is our RHS. Now let's move to the next. And the next question, you can see that this is our LHS, that is in terms of, it's given cosec, and we have to write in terms of cot. Well, all of you know that we have a relation with cosec square and cot square relation with them. Now let's use that relation to find out. What we are going to do is, I'm going to take cosec square theta common from here, right? From the LHS, if I take cosec square theta as common, what we'll get inside? Cosec fourth power divided by cosec square will give you cosec square theta. And this is what? Minus 1. Next, what I'm going to do is to write from here. If you see the identity, I can write from here cosec square minus 1, right? Cosec square minus 1 as cot square theta. So it's important that you know how to transpose and write it. And let's figure out from here. From here, you can see cosec square theta is 1 plus cot square theta, right? I'm not using any different identities, just that I'm transposing this, right? So isolating cosec square from this identity, I say that it is equal to 1 plus cot square. This is 1 plus cot square theta. That's enclosed in a bracket. And for this part, this whole thing cosec square, this whole thing cosec square minus 1 can directly be written as cot square theta. Now, if I open this bracket, is what? 1 multiplied by cot square theta is what? Cot square theta only. And this multiplied by this is cot raised to the power 4 square into square, right? So this is what? This is our RHS. And the next question, I can see the LHS is in terms of Sine theta and cot, sine, cot and cosec, and we have to simplify and reduce it to 2. Now what I have observed that here sine theta is coming common. Well, I've seen that many of you do not take this thing important, and you start simplifying by converting into sine, cos, or whatever other methods used in simplification or proving. But this is very important, right? The sums become very difficult if you do not take things which is coming as common. So I'll take sine theta as common as it is common, and inside what we will get inside the bracket, we are left with 1 in the numerator and cot theta plus cosec theta in the denominator. And then we have a minus in between. Rest is same, that is 1 over. This is cot theta minus cosec theta. Now what you can see, I can take LCM here. So if I solve it taking LCM, that is, this is sine theta only. And inside the bracket, we'll take LCM, and what's the LCM is the product of these two. That is cot theta plus cosec theta into cot theta minus cosec theta. So 1 multiplied by cot minus cosec. So it's going to be cot theta minus cosec theta. Well, for the other part, you need to be careful. That is, this is minus 1 multiplied by cot plus cosec, right? So it's going to be minus of these two. So that is minus cot theta and minus cosec theta. Now what getting cancelled here? I can see that here cot and minus cot get cancelled. So what we are left with, outside we have a sine theta. I'll copy it as it is, and then you have minus minus, that is 2 minus sine. So that means minus cosec and minus cosec is what? What I mean to say that we have minus times cosec theta here, right? Yeah, this is what we have, minus cosec here and another minus cosec here. So it should give you what? Minus 2 times cosec theta, right? So it should give you minus 2 times cosec theta. And below what you can observe that below we have identity, that is cot a plus b and a minus b is what? A square minus b square. So we'll be writing this as cot square theta minus cosec square theta. Now in the next working part of this, I'll copy what you can see, this minus 2. So I'll write minus 2 first, and then sine theta, and that multiplied by cosec theta. Now check in the denominator. This is cot square minus cosec square theta. So we know that cosec square minus cot square is 1, right? So cot square minus cosec square will give you minus 1. One more time, cosec square minus cot square is 1. So cot square minus cosec square should give you minus 1. So you can see that this minus minus here, right? Just the minus minus get cancelled. Finally, what do you know that cosec minus cosec into sine is what? 1. Let's figure out once again. You know that these two are reciprocal of each other, right? So a number multiplied by its reciprocal is 1. So we're finally left with 2 multiplied by 1, which is equal to 2, and that is the RHS. So in the next question, very similar to the previous, here too we are going to take tan theta as common, right? I'll be taking out tan theta as common. So if I take tan theta as common, this is tan theta outside, and inside we'll get what? This will be 1 over, this is sec theta minus 1, and a plus sign here. This is 1 over sec theta plus 1. This is tan theta only, and on taking LCM, this is going to be sec theta minus 1 multiplied by sec theta plus 1. 1 multiplied by sec theta plus 1 is what? It's going to be secθ plus 1, and 1 multiplied by secθ minus 1 has to be secθ minus 1. So what is getting cancelled here? That is minus 1 and plus 1 get cancelled. So what next? We are left with secθ plus secθ is 2 times secθ, right? So I'll be writing 2 first outside, take secθ and this tan theta in product as it is. Below is what I can see. We can apply the identity of a square minus b square over here. So what is a square minus b square? Sorry, a plus b a minus b is a square minus b square. So it's going to be sec² minus 1. So now check from here, secθ minus 1 from here. That is from what you can figure out that sec² minus 1 is tan²θ. So I'll be writing this as 2 multiplied by this is secθ into tan theta copied as the part of the numerator, and I'm writing sec² minus 1 as what? It is tan²θ. Now check here, this there's square times tan, right? So I can cancel this with this tan. Now what next is to convert them into sine and cos. So the rest part I'm doing as writing them in sine and cos. So this is 2 as it is. What is secθ? It's 1 over cos. So this is 1 over cos theta. And what is tan theta? That's sine by cos. Sine theta is tan theta, right? I'm talking about this tan theta here. So we know that tan theta is, where is that? Yeah, it's here, sine over cos. Now check here. Dividing by sine by cos is same as multiplying with its reciprocal. So instead I'll write cos theta by sine theta. Well, it's easy to understand that I had to divide it by tan, which is sine by cos. So I multiplied by cos by sine. So here cos and cos get cancelled. So we get 2 multiplied by 1 by sine, right? 1 over sine is what? Cosec. So I can write directly as cosec theta. So this is equal to RHS. Well, please do comment on whatever, irrespective, good or bad, whatever you're finding this video. And this way actually helps me to exchanges whatever needed. Let's come to the next question now. In the next question, we have LHS has this, and that's an MCQ, and we have to see which is the RHS. Well, irrespective, whatever it is, I must first simplify them. So I'm going to write sec and tan in terms of sine and cos. Well, sec is 1 by cos and tan is sine by cos. That's what I'll do. So I'll write sec, which is what 1 by cos. This is 1 by cos theta plus sine. And what is sine here? Sorry, tan, which is sine theta by cos theta. And outside it's what? It's 1 minus sine. It's not theta, it's a. Why I'm writing theta? Well, if it is a, it has to be a only. All right. So you can see that the LCM is what here? Cos theta only. Oh, sorry, cos a. And this is 1 plus sine a. And outside it is 1 minus sine a. So now I'm going to multiply this, right? I'm going to multiply 1 plus sine and with 1 minus sine. So using the idea that a plus b into a minus b is what? A square minus b square, right? So 1 plus sine into 1 minus sine will be 1 minus sine square theta. 1 minus sine square a, and that divided by cos a. Well, what is 1 minus sine square? That is cos square. So this is cos square a, that divided by cos a. Well, we have square times, so this get cancelled and we get cos a as the RHS. So the correct option will be B here. Well, in this question, the last one is easy, but it's very tricky, right? So I find that all of you actually keep on converting them into sine cos, and many of you are not able to figure out what is sec theta. Well, this is, as I said, it is a bit tricky. What I'm going to do is, first I'm going to write this identity. Now you may be wondering, why should I write? Because there is no square here. This is because I can write, I'm not starting with LHS or RHS. I'm simply writing this identity, that is sec² minus tan² is equal to 1. And using the algebraic identity, that is a square minus b square is a plus b into a minus b. So it's going to be a plus b that multiplied by a minus b, that is a minus b, that is minus tan theta, which is equal to 1. Now figure out that we actually know the value of sec plus tan. We know the value of sec plus tan, which is 1. So if I replace this with 1 here, that's x, right, not 1. So we can see that we can now find the value of, by transposing, we can get the value of sec minus tan, right? This is equal to 1. So if I transpose, I'll get sec theta minus tan theta is equal to 1 over x. And that should be our answer. Now we'll end the video here only.